This land of ours is a land of many people, a land of peace. But even peace has its price. Over 250,000 of our people are working on one means of preserving that peace, working to make the price of war too high for an enemy to risk. Across our nation, these people are rapidly assembling a deterrent to war. In the event of a nuclear attack, retaliation, inevitable, immediate, devastating. That certain deterrent, Minuteman, a comprehensive weapon system, the product of accelerated development. If nuclear war is forced upon us, the enemy will choose his own time. Time is precious. To save priceless time, only 5 years were allotted to develop the entire Minuteman system, from concept to completion. In a weapon system, the missile is important. But a weapon system is far more than just a missile. It's that, together with all that's needed to build it, maintain it, and use it. And the job of designing, building, testing, and fielding it in 5 years is a big one. Current plans call for rapid completion of 5 Minuteman wings, the first 4 located in Montana, North Dakota, South Dakota, and Missouri, and the 5th in adjacent areas of Wyoming, Colorado, and Nebraska. At Ogden, Utah, missile assembly facilities. At Vandenberg Air Force Base, California, a facility for training the men who will man the system. The first operational base covers an area the size of the state of Maryland. Spread across 27,000 square miles, 150 missiles are being stored at the ready in underground launchers, protected within the earth against enemy attack. Buried cables covering these many miles form a communications link between all launchers and their underground control centers. Each of these control centers monitors 10 launchers, checking operational readiness and, if the requirement ever comes, launching the missiles. Operation of a Minuteman facility requires only a minimal team of trained personnel. For the deterrent system to fulfill its purpose, all of its parts, the missile, launchers, support buildings, transportation and maintenance equipment, and trained personnel had to be ready in the same short time. To ready them together in the time allotted meant they had to be developed together. No part of the system could wait for another. All grew concurrently. The concurrent development concept set the pace from factory to field. To keep up this pace, direction throughout development of the Minuteman system is provided by the Air Force Ballistic Systems Division. A team of 7 associate contractors of demonstrated capability was integrated into the fast-moving tempo. These, in turn, selected over 3,000 subcontractors to help with the big job. These civilian contractors and over 50 federal and military agencies completed the industry, military, and labor assembly team. With the team members selected, the plan for protection is becoming in just 5 years an awesome deterrent force operated by the Strategic Air Command. To ready all parts of the system and ready them concurrently, a coast-to-coast assembly line has been formed. Aerojet, Autonetics, Avco, Boeing, Hercules, Sylvania, Thiokol, and other team members have extended themselves into the field, building on the spot the entire weapon system. Executives and electricians, draftsmen and directors, managers and mechanics. Each is a vital part of the nationwide assembly line, pushing the weapon system ahead from design to delivery. Under BSD's direction, planning of all phases of the missile system proceeded. In Air Force offices, in the conference rooms of industry, and out on the production line itself, all parts of the system progressed in unison, and the plan became a reality. A series of full-scale tests was accomplished, first at Edwards Air Force Base, followed by flight tests at Cape Canaveral. Every aspect of the new weapon was studied. While the missile itself was readied for test flights, other men evaluated the assembly methods. The work done by these technicians saved both time and money in later operations. Ground handling methods were given their trial, using equipment still in the early stages of development, and still other men, specialists in electronics, checked out the complex launch and guidance equipment, the system's electronic brain. Even while flight tests were underway, the site survey team selected Hill Air Force Base in Utah as the place for assembly of the missile. To make way for the new system, 40 bunkers for storage were remodeled. Roads were created. And the activation of 9 missile assembly buildings progressed. As the number of operational flights was multiplied, these buildings were readied one at a time, keeping pace with the rest of the growing system. Moving toward the system's first delivery date, work on the home of the first Minuteman proceeded in Montana. The site survey team evaluated 3,600 miles of roads in the Great Falls area. 1,100 final right of entry permits were required for the base sites, and 2,500 for the 2,000 miles of underground cables. Then and only then could the ground be broken. Acting as the construction agents for the Air Force, the Army Corps of Engineers and its contractors began the brick and mortar construction work. In an open cut, the holes for the launchers were dug out to a total depth of 90 feet. Cement foundations were poured, and the growing launchers were ready for steel liners. Curved sheets of steel were welded into 80-foot tubes. Construction men then lowered the 21-ton liners into their ready excavations. The outer part of the launch tube is formed of cement. 881 cubic yards are used to complete the launcher. About the upper part of each launcher, facilities are provided to house the automatic equipment for checkout and launch of the missile. The rough construction completed, the openings were filled, and the surface work was done. Launcher lids are constructed on site of steel-reinforced concrete, 80 tons of protection for the missile below. Concurrently, work progressed on the launch control facilities. Steel frameworks are augmented by concrete shells 4 feet thick. Access to the shelter is through a 60-foot tube, built up in the open prior to backfilling. Cables containing up to 100 pairs of wires form the electrical communication link between the 50 launch sites and 5 control centers, which make up a squadron. Laid beneath the surface and having alternate routes for signals to follow, these links provide the Strategic Air Command alert crews with constant communication. Keeping pace with the facility's construction, a site activation support area for use during buildup was established. Equipment was moved in for testing and assembly of the system's complex electronic nerve center. The necessary administrative, records, and accounting areas took shape. Here, plans were disseminated, progress was recorded, information vital to program management. Several dispatch areas in the field near the remote sites provide availability of equipment to assemblers on the spot. The first equipment assembled into the launch sites is for heating and cooling. The missile, with its solid propellant engines and its sensitive electronic system, must be kept within a prescribed temperature range 12 months of the year. Within the launchers, the underground cable connections are completed, and other assembly crews began their work. Inside the launch tube, fixtures for suspension, alignment, and support of the missile were put in place. In the equipment room, the guidance and control umbilical cable and the emergency power equipment were added to the system. Electronic equipment, programmers, communications, data processing, and missile alignment equipment are housed here. Security equipment to generate an alarm signal should there be any intrusion into the launcher area was also installed. Along with the missile sites themselves, assembly and checkout teams equip the strategic missile support base. Electrical, mechanical, and communications maintenance, equipment storage, and repair are centralized in this area. Facilities were activated for aircraft or rail unloading of missiles. And for missile transfer under controlled temperature conditions. Strategic Air Command crews to maintain the operational launch sites are dispatched from the support base. While assemblers move on to apply their experience to other launch sites, the subsystem checkout is begun on those just completed. Programming, launch, test, and calibrate circuits, environmental control, and alarm systems are evaluated. Proper function of each item is ensured, even while final electrical connections are being made. As each new launch site is completed, it too is tested until a flight of 10 is integrated into a working unit. With launcher and control center connected together, integration testing to ensure proper functioning of the entire system is conducted. Assembly line technicians feed various predetermined test signals into the system. All command and monitoring functions are thoroughly tested until proper performance of the integrated system is proven. When these operations are completed at the launch site, the launcher is ready to receive its missile. From its Utah assembly line, the missile, ready for emplacement in its launcher, is transported to the remote bases by the Air Materiel Command. For this purpose, a special shipping and storage container is used, providing temperature and humidity control throughout transit. The ability to be transported by air ensures rapid on-site availability of the missile. Upon delivery to the support base, the missile is transferred to a special vehicle, the transporter erector. The transporter erector, like the shipping container, is designed to provide proper transport environment for the missile. 5 contractors helped evolve this 20-ton vehicle, 65 feet long, 13.5 feet high. As a part of the operational system, the transporter erector provides a time-saving means of emplacing the missile without the use of other special equipment. Alignment of the missile, test and calibration of its guidance system and its security system integrate it into the launch environment. The weapon system is then ready to be manned by the operational crews. To ready these men, early classroom training progresses at Chanute Air Force Base in Illinois. Highly specialized Air Force instructors are supported by civilian technicians. Even before the missiles they will man are built, Strategic Air Command crews receive final intensive training at Vandenberg Air Force Base, where a complete Minuteman launch complex has been established. Strategic Air Command missile men are experienced operators of the weapon system on its delivery day. Delivery day. The day a flight of 10, along with its support facilities, is completed. As other flights are completed, the system grows. 5 at a time, the flights are integrated into squadrons, and the finished squadrons grow into wings. In this manner, the entire weapon system is assembled, spreading across the face of our land as fast as men can build it and deliver it. At the end of the assembly line, the Strategic Air Command accepts the system. One flight at a time, the plan for production becomes in the hands of the Strategic Air Command, an operating force. Minimal manpower requirements are the key to the economy of the operating system. A small crew of men, dispatched as needed, provides all maintenance for each wing. Within each of the 800 launchers, a ready missile waits, unmanned, months at a time, without maintenance. Inside the launch control centers, shielded beneath 80 feet of earth and barricaded behind an 8-ton steel door 4 feet thick, 2 men, rotated every 24 hours, keep a round-the-clock vigil. Within this steel and concrete shell, these men monitor the entire weapon system, maintaining the promise of instant reaction to any aggressor. Operated at a price we can afford to pay, Minuteman, if needed, can retaliate in less than a minute. From design to delivery, the nationwide job of assembly and checkout in the field is finished. A deterrent to aggression, ever at the ready, the Minuteman system has grown into reality.